Hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 79,000 computing professionals and students who are ACM's members. I'm Eric Meyer, Director of Engineering at Facebook and founder and CEO at Applied Duality, and of course a big Kotlin fan. You can find more info on my background in the bio widget on your screen. For those of you who may be unfamiliar with ACM or what it has to offer, here's some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. For example, ACM provides timely computing information published by ACM, including communications of the ACM and Q magazines. Both I can highly recommend. Access to the ACM Digital Library, the world's most comprehensive database of computing literature, which I can browse nearly every day. International conferences that draw leading experts on a broad spectrum of computing topics, and support for education and research, including curriculum development, teacher training, and of course the ACM Turing and ACM Prize in Computing Awards. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown in the slide in front of you. First, the slides will advance automatically through the event. In this case, there will be no slides. There will be demos. On the bottom panel, you find a number of additional widgets and resources. If you're experiencing problems with the slides or audios, press F5 in Windows, Command R on the Mac, or refresh your browser on a mobile device. And of course, you can always close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during the webinar, please type them into the QA box at any time during the webinar and click at the submit button. I'll organize the questions as Hadi speaks. And in this case, we'll take questions as we go. And maybe if we miss some of the questions, we'll address them at the end. The session is being recorded and will be archived. You will receive an automatic email notification when it comes available. And check, of course, learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you will see a survey on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the link to the survey at any time from the resources window on your screen. You can also use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using hashtag ACM Learning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after this webcast, including questions we won't be able to get through during this session. Today's presentation is What Can Kotlin Do For Me by Hadi Hariri. I'm really pleased to introduce Hadi. He is the VP of Developer Advocacy at JetBrains. His full bio can be viewed on the bio widget of your screen. Hadi, without further ado, take it away.
Thank you, Eric. And it's a pleasure to be here. And it's even more of a pleasure to have you alongside me. And as I was saying beforehand, it's awesome that you're going to help me with the questions because essentially you know more Kotlin than me at this point. Because you've been twisting and turning the language as much as you could to see what it can and can't do. So thank you. And thank you to ACM for having me on. So thank you everyone also for joining. I do hope that you can see my screen and see and hear my voice more or less okay. And yeah, in this short 45 minutes or so, what I'm going to focus on is explain a little bit what the benefits of Kotlin are and what it can bring to you as a developer. And of course, I'm going to have to compare this with something that many of you may be familiar with, such as the Java language. But in essence, you can kind of compare this to any of the other languages that you are used to, whether that is C# or JavaScript or whatever it is that you come from. And the main goal of Kotlin, if you are not familiar with it, is that this is a language that we started in 2010 at JetBrains. And the idea was to try and create a language that was concise, more concise than Java, which I always say it's not setting the bar too high, but we still try to make it concise. Something that is toolable, because as a company that makes IDEs, we strongly believe in tooling. Something that is safe, and we'll get into the details of what that exactly means later on, and something that is at least as fast as Java. In terms of the compiler, in terms of runtime, there's literally no difference. And I'm glad to say that the majority of the goals we're kind of accomplishing. It being as fast as Java, not quite there yet, but it is getting there. And one other factor was we wanted a modern language. Now, what do you classify as a modern language? It depends who you ask. You know, like some people would say, oh, a modern language is a language that is functional. Not forgetting that many languages back in the 70s were functional as well. So, but anyway, we try and bring lambdas to the table, so to speak. So I'll start off with some live coding, and then we'll see some of the demos that I have prepared. But one of the things that we can start off with very easily is the Kotlin is essentially allows you to have top-level functions. So one of the things that we want to get away from is the ability to have, or the forcing you to create classes to hold functions. And I want to make it very, very clear that Kotlin is an object-oriented language. It does have functional paradigms. If by functional languages we adhere to, I think Eric used to say this, languages that treat functions as first-class citizens, as primitive building blocks. So, by all accounts, you can have classes and objects, and we'll see all of that. But to create a function, like you can just take a file and create a function in it, and that becomes a function that you can use. Very similar to JavaScript, as I always say, but in a good way. And what I've created now is kind of the top-level function main, which following this signature of certain parameters and an array of string, and a function called name means that it is the entry point to the application. So if I just write print hello, that will I can run that at any point, and that's going to print hello in the output screen. So you compile it, and you can see the output screen here at the bottom. Now, let's try and see where we enable you to do more or actually write less, and what we offer on top of something such as Java. So let's create a new class, and we're going to call this, for example, my customer. So I'm going to create a class called my customer. And in this class, I'm going to create a property of type ID name ID of type integer. And I'm going to create another property that is called name of type string. And the signature is following the Pascal notation, which is the name of the parameter followed by the type. And what this is giving me, just so you get an understanding of what this is, what I have just created here, is I've created basically a class with a constructor that takes that has two properties. One of them is named ID, the other one is named name. One of them is read-only, which is designated by val, and the other one is read-write. So let's go ahead and do the same thing, but with Java. So I'm going to create a new file, and I'm going to create a Java class, and I'm going to call it my customer Java. And let's go ahead and do a split vertically so that we can see both things here. So I'm going to switch back here to my customer, and then we're going to switch over here, and I'm going to do my Java one. So I'll do private, and you got to forgive me because it's been a long time since I've written some Java code. And we're going to have name, that's going to be string. And now let's do some magic here. So this needs to have a getter, and then we need to have a setter and a getter for the name property. And then I need to have a constructor which is taking both parameters. Okay, so already you can see that I have just removed a whole bunch of boilerplate code by just simply doing the following in a single line. Now what I'm going to do is I'm going to add a modifier here, which is called data. And let's see what that would mean in Java's term. So override methods, and I'm going to override hashcode equals clone and toString, right? So now I have all of this code in just one line of code over here in Kotlin. Now you say, okay, well, that's not a massive deal because you just generated all that with the IDE. Absolutely. And when we came up with this idea, we didn't realize that, you know, we're taking functionality away from our IDE. That is, of course, a joke. But the point here is that, yes, the IDE does generate this for you. The IDE does not, to date, maintain it for you. So when I come here and I say, oh, you know what, I need to add a new property, then I've got to regenerate that. And when I open this code at some point, I got to try and figure out and see, is this the default generated code that IntelliJ or my IDE generates for me, or has someone been tweaking this? Now, I said that these two are equivalent, but I somewhat lied because, in fact, in Kotlin, the concept of the field as such doesn't exist. So we only have properties. So really this ID and this name, as we see it here, isn't necessary. And to create an instance of a type in Kotlin, we follow very much similar to Java or to other languages. So we just say customer, and then we'll say customer. In this case, it will be my customer. So we don't have to put the new keyword. It detects it. Different to JavaScript, it doesn't care about the camel case of the function name, that it'll be in uppercase. But you know, you don't need to use the new keyword in Kotlin. So I'll say one, and for example, Eric, right? Now, if I do a print line of this, what we'll see is that this is going to give me a nicely outputted string, which is representing the property with name ID and Eric. And that is defined by the toString implementation that the data class has. And of course, I can override this because this, at the end of the day, is a normal class. I can actually go toString and override the toString and define my own kind of implementation for toString. Notice also that the curly braces are not necessary if I don't actually have any members in that class. But the class does give you other things, as we saw. Like, for example, I can say another class here, well, sorry, customer one, another customer, and then do customer, copy, and then that will allow me to copy. And I can copy customer values by default, or I can assign new values over here, and now I get a new one. And then I could do comparison. So, for example, equal comparison, that's going to tell me if the properties are actually the same. So it's going to do a property comparison. If I want to do a comparison by reference, I do the 3 equals sign. Okay, so already we've got a bunch of functionality that Kotlin is providing me without having to write a lot of boilerplate code. And we saw that Kotlin has the concept of top-level functions. So that means that anywhere in any file, I can essentially define a function. So I can say, how do I define a function? For example, print message. I say print message, and then I say the parameter name, which is, for example, the value or the actual message I want to print. And then I will do print line message. Now, I can even have string templating. So I can say my message is, and then put the parameter value in there. And by default, Kotlin functions, if you don't declare a return type, the default return type is unit. And unit is like void, except it's not void. And that's an important distinction, because let's take this function, for instance, here, and I'm going to do print message, and I'll say hello, right? And this is going to run. And if I come here, and instead of doing print message, if I come here and say throw, if I can type, a delay with the webinar software, so this is failing, right? Now this, okay, this line does, the IDE does say to me that this line is unreachable code because it sees the throw, but it's not saying to me that print message is unreachable. And if I write print line hello over here, it's not seeing that this is unreachable, because it is saying by all practical effects, this is returning a value. what value is it returning? It's returning a unit. And we can dive into unit to see what that is. And I'll get to object in a second, but it is returning a value. How can I tell Kotlin that this function actually doesn't return a value? It doesn't return anything. In fact, it returns nothing. Well, in Kotlin, we actually make that distinction. So I can say that this function returns nothing, right? Now, if I put that function, if I make that call there, and if I bring this line up here, you can see that over here now, I should have done that with unit. You would have seen it. It doesn't fail either. You see that it's not detecting that this is unreachable. But if I change that to nothing, you can see that now it will tell you, the compiler will figure out that, well, this isn't returning because it's, you know, under the covers, it doesn't know that it's throwing an exception at this point, but it doesn't care because it's saying this function doesn't return. So we do make the distinction between not returning something, which we call nothing, and returning something, which that something could be an integer in our case, as we saw, or it could be a unit, it could be an integer, or it could be any other type that it returns, right? And for those interested, nothing is basically a public class, nothing with a private constructor. So nothing to worry about really there. Okay, now coming back to these functions, again, talking about trying to cut down boilerplate code, if we take a look at something like overloaded methods in Java, so let's say overloaded methods in Java, we can see that here we have a whole bunch of overloaded methods that all they do is take different parameters. So I have one that takes one, I have one that takes a prefix, I have one that takes a prefix and a suffix. What would be the equivalent of doing that in Kotlin? In Kotlin, we have default parameters. So I don't need to create 3 versions of the same function just because I want to pass in parameters, extra parameters, and sometimes make those optional. In the case of Kotlin, I can just initialize the value to an option to a default value, and then that now becomes optional parameters. So I can now call print message with just 1 parameter of type string. I can call it with 2 parameters of type string. I can call it with 3 parameters of type string. And in cases where you have the actual parameters being of the same type, what you can do is use named parameters. So let's say that I only want to pass in 2 arguments. How do I know which one I'm referring to? Is it the prefix or the suffix? That's where we can use named arguments. So I can say suffix equals 1 and then message equals string. And notice that I can even change the order. And this is useful not only for when I have default parameters, but it's also useful for when I'm actually, you know, having functions that for whatever reason, legacy reasons or whatever, have a lot of parameters being passed in, and I cannot, again, normally you would refactor that and create some data class or something like that for it. But if I cannot, then I can use name parameters to be able to get more insight into what is being passed in each position. What about some other things? So let's take a look at some conditional expressions in Java. So here I have a variable of type string that I'm declaring, and then I'm doing some silly checks to see whether the length is 0 and assigning the value to the parameter. Okay, and below I'm doing something very similar. The difference is that here I'm just, you know, there's an else if, and I'm passing in assigning the value. And then I also have a switch statement where, again, I'm initializing the actual variable, and then I'm doing some different, executing different statements, and then setting the value of actual. Now, notice a few things. Here, I'm really basically restricted to what I can match in the switch statement. Right? There is no such thing as much as pattern matching. If I want to go outside of the case norm, I have to essentially do some default, and then in the default, do some extra logic. And the other thing to highlight here is that I have to initialize a variable to then assign the value. And this is because if and switch are essentially statements. In Kotlin, if and switch are statements, but they're also expressions. So that means that I don't need to initialize some variable and then assign the value. So you can see here that I have, for instance, here I have a single line if and I'm assigning the value of the result of the if expression directly to the parameter. Here you can see that I have if with a couple of else branches, and notice that this one over here has multiple statements. So the idea here is that I can write as much as I want, do as much as I can, and then the last line is the value of the return statement, the value of the if expression that's going to be assigned to the value that is going to be returned from the if expression. And you can even return different types. So for instance, if I put a type string here, what's going to happen? It's going to say, well, now the conditional branch is of type string, which means that value is now implicitly assigned a type any. Okay. So normally the compiler would warn you, because rarely you want to do things like that. Normally you'll be returning the same type. And that's another thing that you might notice. Like, we try to be very concise in Kotlin. Val, when I declare a variable of type val, and I say that this is, for example, 10f, which is 10 float, I don't need to explicitly initialize this. I don't need to, explicitly declare the type. I could, if I wanted to, and then initialize the value. So I can say that this is of type float, and then the value is 10. But in Kotlin, you can just essentially just initialize. And this doesn't mean that it's dynamic. We're not talking about var in JavaScript or the dynamic type in C#. This is just saying it's just type inference. So the compiler is able to figure this out. And it's the same thing with functions. So for instance, with functions, if I do function sum, and then I'll do, let's say, for example, my sum and x of type int, y of type int, and then I could do return type int, and then return x plus y. That's a lot of code to write for a little thing that I want to do, right? Which is just return x plus y. I could write that in a much shorter way by just essentially doing x plus y, right? So what that is essentially the compiler, again, is inferring the return type. It knows the parameter types, so then we don't have to explicitly indicate what the return type is. And going back to the example, because we were talking about if statements and switches, in Kotlin, switch is represented with the keyword when, but notice that Kotlin expands beyond just case values. Here, what I can do is I can do a little bit more effective pattern matching, so to speak. So I can check for individual values. I can check for ranges. I can check if it's a specific type. I can check whether it is actually in a range. This is multiple values. Sorry, this is in a range. And I have my else branch as well. And much like an if that can act either as a statement or as an expression, a when can also act as a statement or as an expression. The idea here is that, you want to try and move towards the expressions there and minimize the potential side effects that you could have. So one of the things that we were trying to do with Kotlin is make sure that the code that we are writing is kind of expressive, right? So, data classes, we actually have something in Kotlin called tuples, which you may be familiar with. So I can say, for instance, I can create a pair of values. I can say val pair equals a pair of 2 and 3, right? And that would create a pair of 2 strings. And initially, we had the concept of tuples, or tuples, which essentially means that I can create a variable number of values being returned. Now, right now in Kotlin, you could basically, we took that away, and now you can have basically pairs, and then you can also have triples. And beyond that, we recommend that you use a data class, right? Because the data class does add expressiveness to what you're trying to do. It provides more semantics. But when I have this pair, let's say that I have this pair over here, and let me go and provide some values here. So let's say, well, I'm going to call this Madrid, and I'm going to call this Spain, right? When I'm operating on this, how do I operate? So I can say, for example, print line pair, and then this is going to be first, okay? So from one side, I'm saying to you that we want to provide you with semantics. From the other side, I'm saying to you, okay, but now refer to this as first. And that doesn't look too good. So what you can do, in fact, in Kotlin is do destructuring. So here I can say, instead of calling this pair, I can say this is, for example, the country, and then this is the capital, right? And then refer to this as country and capital, right? And in cases where I'm not even going to use one of the values returned, I can just replace it with an underscore. And that way I get rid of the compiler hint, which is saying that this value isn't being used. And this is not just applicable to pairs. This is applicable to essentially everything that you could, anything that could be destructured, from lambdas to data classes. I mean, I can create, for example, a data class here and say my customer, and let's provide some values over here. And instead of referring to this as my customer, I can say, I don't know, customer name, customer ID, and then customer name, right? Much the same way. Okay, so you can destructure, and if that had 3 values or 10 properties, you could destructure 10 properties. It's essentially following the convention. Now, some other things that Kotlin provides us that tries to cut down boilerplate code. Here is a simple example of something you shouldn't do, or downcast a specific instance, or the violation of the law of Liskov, as you would say. So here I have a method which is called create segments that takes an object, and then I say if object is instance of view, then cast the object to type view and initialize it, right? So the compiler knows in this case that this is an instance of type view. Why do I have to do that extra cast? Well, in fact, in Kotlin, you don't need to. In Kotlin, I can just say if object is view, then initialize it. Automatically, now the compiler is saying, okay, I know that this value is not going to be changed as long as it knows that it cannot be changed from another thread or what have you. I can now initialize this, treat it as an object of type view. And you don't have to go ahead and write all of that typecasting code over and over again for me. And this actually works, and you can see that the ID is highlighted and it says to use smartcast to com.hadihariri.com demos clean, because it can check that. And typecasting works somewhere else as well, which is with nulls. And if you remember when we started, one of the things that I mentioned is that we wanted to try and make the language safe. Now, obviously, safe is an overloaded term out here, but one of the things that we wanted to try and get away from is this continuous null reference exceptions or null pointer exceptions that pop up in our code at runtime. And you're often also known as the billion-dollar mistake. So what does that mean? That means that when I do something like val message equals some value, well, first of all, I cannot reassign this. And I cannot reassign this to something else because it's val. It means it's read-only, final, in the words of Java. So I would say var. Now I can reassign. But I can never assign null to this. If I assign null, it says that null cannot be a value of non-null type string. And that is because this, by default, types in Kotlin cannot be nullable. So what I'm writing here is the implicit version of declaring explicitly the type string and initializing it to some value. And a string can never be null, just like an int can never be null. But what happens if I want it to be null? In fact, one of the great things about Kotlin is that 100% interop with Java, right? And we'll see an example of this in a moment where you can actually mix and match. In fact, you can see here that I have Java code base and Kotlin code base in the same project. And you know, we all know that when we're talking to Java, there's going to be nulls. So we need to also have the ability to represent the nullable type in Kotlin. And how do you do that? Well, you add a question mark to the type declaration. As soon as you add a question mark to the type declaration, now that type can actually, that variable can hold a value of type null. So if I write, for example, print line message length, now here it's going to say to me, yes, but this is of type null, so this can cause a null reference exception. So I can say, well, then what we can do is just say not null, if message is not null, then let's move this up over there. We say if it's not null, do that. And then you can see that this goes green again. And it's what it's doing is doing again a smart cast. Just like we saw before here with the smart cast, it is smart casting it and saying, okay, this is not null. Now, this goes back and says, okay, well, this is quite a bit of boiler code because I need to write this every time, and you keep telling me that Kotlin's cutting down on boiler code. You're lying. Well, I'm not. What you can do is, in fact, make this a much shorter way by just adding the safe operator. So the safe operator says, if this is null, then invoke length on it. If null, if it is not null, invoke length on it. If it is null, then don't invoke length. So what would the result of print line be? Well, the print line is going to print the contents of that. Since that message is actually null, if it were null, it would just print line the representation of null, which is the string null. So, I'm going to run this, and it is not going to blow up at runtime because it's going to print out the length. But if I were to run this with a value of null, in principle, let's see what happens. I can say null, and this won't give you a null reference exception. And it will just print out the string null. Now, if you want to be extra smart and say, you know what, I know that this can potentially be null, but let me go ahead and because I missed my null reference exceptions, let me go ahead and cause a null reference exception. It's there. We have Kotlin null pointer exception for whenever you miss those things. And this is a funny thing because you're kind of like, why would I have that? You shouldn't. When would I use that? You wouldn't. Why is it there? I don't know. Very rare case it is there. But given that Kotlin and Java is quite interoperable, when people usually start to convert their code from Java to Kotlin, or when they're calling Java code, often they say, oh, well, this is saying that it's null and I'm not really sure. But I need to make sure that it's always called, so I can't use the safe operator. So let me go ahead and do the double hashbang. And then they get null pointer exceptions at runtime, and then they're like, oh, you told me that Kotlin is safe and Kotlin is not safe. You shouldn't do this. What's happening with Kotlin, when we're eliminating null from the language for you, it's actually forcing you to think about null more. It's forcing you to think about the non-happy paths. What would I do? What value do I expect if this is null? Should I have a default value? What is it that I should be expecting if I go down that unhappy path? And how do you interop with Java? Because, I keep talking about interop with Java. Well, here I have a Java customer Java, right, which we saw similar to the one that I created before. Very simply, I say val customer equals customer Java. And then customer Java takes some parameters. It takes an integer, it takes a name, and it takes an email. There you go. And now I say customer. Now this is Java. If I'm writing Java, I'm going to write get email, but I'm not writing Java. I'm writing Kotlin. Kotlin, you don't have getters and setters. You just use properties with property accessors. So I can say email is mail@hadihariri.com. And there you go. And if I want to print line value of the property, I can say customer.id. And I could write get ID because it's Java. But as soon as I do, the ID says, you can use a property accessor. You don't need to write it like that. And just mix and match. This is Java code. And let's go to that Java code. And let's come down here and let's create some Java code. Let's do PSVM. And now let's mix and match the other way. I want to use a Kotlin class. So I'll say customer equals, I'm in Java, so new customer. And this takes a name, and this takes a email, and this takes a semicolon. And remember, well, don't remember because I didn't tell you, but notice there are no semicolons in Kotlin. If you want semicolons, you can add them, and then you can invoke the code cleanup and get them removed because semicolons are optional. They're there if you want to have debates of whether or not you want to use them. Generally, you never have to use semicolons except in one specific case with enums. Otherwise, they're completely optional. Now, coming back to my Java code, customer get email, right? And I don't have a get email in Kotlin. Over here, I don't have a get email, but it is taking care of providing me an idiomatic approach to accessing Kotlin code in a Java-esque way from Java, much the same way it is giving me an idiomatic way to access Java code in a Kotlin way from Kotlin. And that is the mix and match interop of Java and Kotlin. And we can see this even more. So for instance, here we have Java nulls, right? I have a customer in Java that is being passed in. So you have your typical chain of if customer is not null, if get name is not null, then customer get name starts with A. How would I do this in Kotlin? So Kotlin nulls, and what I have here is this is a customer Kotlin. So it's not null. I have zero problems. I don't have to do any null checks. Now, let's go ahead and use a customer Java. As soon as I use a customer Java, right, you see, there is no null checks either, because I am saying to Kotlin, I'm using a customer Java, but the customer Java isn't nullable. So I don't need to do null checks. Now here, down here, there is a version where I've added the question mark and I'm saying it is nullable. And that means that now the compiler will check. And if I remove this safe operator, it's going to say to me, you cannot access this because you're saying that the type you're consuming is null. So you might ask the question of, then how do I know? Well, when we first started to work on Kotlin, what we did was essentially say anything that you consume from Java is nullable. So you didn't even really have to add the question mark. It was essentially there, and it was saying that, you know, this is Java, it is nullable, therefore you have to do the check. And what happened is that we ended up with people using Kotlin and having lots of code bases with the safe operator, which kind of looked really ugly. So we said, okay, let's create some annotation that basically runs through the code base and the libraries that you're using and annotates those that are not nullable, and then you don't have to explicitly use the safe operator. But that didn't go so well either. So we did what any good consulting any good consultant would do or say, and say, well, you know what? It depends. When you decide that the type that you are getting back from Java, whether it's a type you're passing in, whether it's the result of a method you're calling or whatever, when you decide that that is nullable, then you add the question mark. When it is not, don't add the question mark. And of course, this does lead you to a situation where you actually, again, have to think about the code that you are consuming from Java. If you're just writing Kotlin code, then suggestion normally is don't use nullable types and restrict the use of nullable types only to when you positively have to use it from Java. And still, even then, you can use some of the annotations for not null, etc., to make your code base a little bit cleaner. Now, one thing also that differs from Java is the actual hierarchy of classes, right? So let's go back to placeholder and let's get rid of all of this. And not the package name. Let's keep the package name. There you go. Okay. So let's say I have a class which is called person, right? And then I have a class employee, and we say class employee is of type person. As soon as I do that, I can't. You see that I get a red squiggly, and that red squiggly means that person cannot be inherited from, because by default classes in Kotlin are final. If I want to inherit from person, I have to explicitly mark that as open. Once I do that, then I can inherit from it. And the idea here is going back to the roots of, as recommended also in effective Java, which is, you know, you have to think about your inheritance change. Don't just go, you know, jumping around and declaring your classes open, because we all know that long inheritance chains often don't provide us with great results. Now, okay, this is the, and to be clear, if you're using something like, you know, IOC containers or frameworks that require classes to be overridden, or sorry, to be open, there are plugins, for instance, for Spring Framework. There are plugins that essentially allow you to treat classes as open and allow Spring to work correctly without you having to go around decorating all your classes. But this does lead us to another question, which is, what about when I want to extend the type, right? So let's say that I have a function. I have a type called message, and that's going to be like, this is my name. And now I say this is of type string, right? Now I want to see if message is similar to another message. So I can create a function and say is same as, and then pass in another value of type string, and then I'll say value equals this, right? So, sorry, not this. Value 1 equals value 2. So value 1, comma value 2 of type string. I normally don't type so bad, but it's this delay that's killing me. Value 1 equals value 2, right? Typical string. So I can now say, you know, is same as, this is my name, to message, right? Typical function, nothing. The problem is that, you know, because I don't have a function in Kotlin, string, the type string doesn't have a function that's called is same as. I mean, it has equals, but maybe I just want to call it is same as, or instead of is same as, I want to say, I want to create a function that says to camel case or whatever, right? What are my options there? I would have to inherit from the type. Now, if this is a Java type, I would have to inherit from the Java type. If it's a Kotlin type, I have to declare the type open and inherit from it. But in Kotlin, we have a similar function to C#, similar functionality to C#, which is called extension functions. And extension functions essentially allow you to extend the class by adding new functionality to it without having to inherit from it. And all I need to do is just prefix the name of my function with the name of the class. As soon as I do that, what happens is that now I'm basically extending that class string with a new function called is the same as. So first of all, we get rid of the first parameter. And now, since I have only one parameter, what do I compare this with? Well, this is an extension to the class string. Since it's an extension, I'm going to have an instance of that class, which is always referred to in Kotlin by this. So what this means is that now I can do message is same as, this is my name. So now I've extended the message with is same as. And for those of you wondering, where does this have effect? This has effect where the package is declared. In the package is declared. So if I've declared this in Hadi Hariri demos Kotlin live, as soon as I include this package, my type string will have this new extension function. And if you're using an IDE, like for example IntelliJ, completion will still provide it for you, but it will show you that it's an extension function, and then it will automatically import it for you, right? And this is nice. And then I could do something like, for example, you know, message is same as, this is my name, right? And it says to you, no, you can't. And I say to it, yes, I can, because what I can do also in Kotlin is any function that takes a single parameter, whether it's a member function or an extension function, to all practical effects, it is a member function, then I can call it also in infix notation, right? And now different to C#, although I believe C# is now adding this, we also have extension properties. So for instance, I said that I can write, for instance, a long, I can say 100L. I can write a float as 10F. I can write a big decimal as big decimal 100, which kind of sucks, right? I don't want to have to write big decimal. I would rather write val bd 1 equals 100 bd or bd. I can't do that, but I can do the next best thing, which is add a dot, and then here I can say create an extension property on type integer that returns a big decimal. And then that is going to do return of big decimal, return big decimal of this, right? So you can see this is also an example. This is not only an example of an extension property, but it's a custom getter as well. So you can have custom getters and setters in Kotlin, which we didn't cover. So now we can have extension functions and we can have extension properties. What else do we have in Kotlin that tries to make your life easier? So here, for instance, there's another thing which is called the type alias, right? And the type alias is essentially the ability to make a synonym of another type. So for instance, here I have a type alias customer name that is essentially a type string. So I can do customer val, customer name, and val email string. This is the same thing. There is no customer name at runtime. At runtime, it is a string, but it's providing me with a few more semantics. And type aliases are, if you're familiar with Haskell, it's different to the concept of a new type. It literally is just a synonym, but it provides you with some nice things that you can do. For instance, here, there's a annotation in Kotlin which says deprecated. And deprecated basically means that a class is deprecated. And I can say that I can provide the message, and I can say replace with to provide insight into what that class has to be replaced with, right? And then I can say the type alias here is, then I've got a new, let's say that I want to change customer to now be called awesome customer, right? So I can say that type alias, we can say type alias awesome customer equals customer, right? And now, or the other way around, sorry, customer equals awesome customer. Actually, no, I got that the right way around. That should be awesome customer. Awesome customer equals customer. There you go. So now I have to get rid of this one over here. Let's say that this is customer. Okay. Now what happens is that I haven't actually renamed my customer. What I've done is introduce a type alias called awesome customer. So this is like a way that if you have a public API, for instance, and you want to rename things, you can do a phased rename for your consumers so that you don't end up breaking their usages of it without giving them warning. And you can use something like a type alias and say type alias customer is now of customer, and then add a deprecated to your type, your existing type customer, and say customer is now called awesome customer, replaced with awesome customer. So now when your user is using this code, when they hover over, it says, oh, customer is deprecated. Oh, look, Alt Enter, and I replace it with awesome customer. Then in the next iteration, you can actually remove the type alias and finally rename your customer to awesome customer. And then that basically provides you a two-phase migration for your customers, which they'll greatly appreciate. One thing that I showed you initially when we talked about functions, we talked about unit, and I said that it's different to just void. And that is true, and that's because we have the concept of objects in Kotlin, and unit is an object. This is something that you're probably familiar with, a singleton. In Kotlin, in Java, you create a singleton. You memorize the pattern for a singleton. This is how you do it. There's a few patterns, but this is as good as any of declaring a singleton. How do you do this in Kotlin? In Kotlin, you just create an object. We have the concept of top-level objects, of objects, not just, an object can be an instance of a class, but we also have the concept of an object, which is basically what JavaScript has. So if I want to declare a singleton, I just call in an object. And you can use objects, you can have objects implement interfaces, you can have objects inherit from classes, anything you like. Anything that is just going to have a single instance, you can use it. And one thing that we haven't touched up on, but I want to, initially when we talked about Kotlin, and I said that this is an object-oriented programming language with functional constructs, is because we do have functional constructs, and we have top-level functions, and we have higher-order functions. And we're going to finalize this session with seeing some of these things that we have with functions. So we already saw extension functions, and we saw infix functions, but we also have higher-order functions. So let's say that I have a function that says operate, and that function takes another function of type x, y, and it returns, takes a function of type integer that takes two integers and returns an integer, okay? Now this is a higher order function because it's taking a function that takes the signature of two integers, returning an integer. And then I could do something like, for instance, operate, and then declare some function that does this. Well, for instance, sum. My sum is an example of a function that takes two integers, that matches that parameter. To refer to a function by name, you can use my sum, colon, and then the name of the function. But we also have the ability to have lambdas in Kotlin. So I could just say, for instance, x, y, and then x plus y. Okay. And in Kotlin, if the last parameter to a function is another function, I can in fact remove the brackets and just pass it like that. And in fact, I can even do multi-line, something like this. And you're thinking, why would I want to do it? Well, it looks nice, but also it allows you to, in a way, extend the language with new quote unquote keywords which act very similar to constructs of the language. For instance, in Kotlin, we don't have the concept of using, which would
Hadi?
be, yes.
There's a question about, like, if you look at your code here and the arrow, you know, where it kind of like turns like, you know, dash kind of greater than into get like a nice Unicode character. A lot of the kind of like questions are about what is the magic behind that.
Right. Okay, so I've been talking for 1 hour about Kotlin and you're asking about the IDE. Awesome. That is the font ligatures over here. Enable font ligatures, and that will basically give me the nice little arrows and the greater than and all of these things. And then all you need to do is just enable the Fira code. So that is not a Kotlin feature. You can see it change over here. Okay?
People like beauty, so.
Yeah. Right. So, so one thing that we have is a using statement. So in C# you have the concept of a using, which basically is you have a type which is implements the iDisposable, which means that when I finalize working with it, I dispose of it, and you can wrap this in a using statement, which makes sure that it's always disposed of, which would be kind of equivalent to try with resources on a closable object in Java. But I could create something like that. I could say I have an object. We don't have it in Kotlin, but I could create it. I could say I have an object that is a closable, and then I have a block of code that takes no parameters and returns nothing. And then what I'll do is I'll do something like try. And then here I'm going to do execute my block of code. And then finally, I'll do object close, right? And now this means that now I can write something like this using, and then let's say that I have, for example, my object, which is of type closable. And then now I have this syntax over here, right? So imagine that this exists. That's just going because it doesn't exist. So that now means that I've created this kind of like construct, so to speak, in Kotlin, which allows me to guarantee that, you know, whatever is a closable type is going to be closed automatically, and I don't need to worry about that, and the developer doesn't need to worry about that either. And of course, this is just some of the things that I've shown you with higher order functions and with lambdas, and Kotlin taking into account a bunch of things such as the ability to have extension functions, top-level functions, higher order functions. All of these things comes with a small standard library which provides you a wealth of functions that you're normally used to when you're doing functional programming. So for instance, if I say numbers equals 1 to 100, you know, all of the things like the beauty of things like filter, you know, where the it is less than 20, and it is another convention similar to Groovy in that if a lambda takes a single parameter, I could just refer to that as it without having to be explicit. And then I could do something like map, and then, you know, like map that times 20, and then, for instance, sorted by and sorted by it, etc. All of these are part of the small standard library that comes with Kotlin, which is essentially a wealth of functions, extension functions on collections that allow you to do all of these different operations that you can think of. And if you're noticing here, there's one other thing here called inline. You might be wondering what that is. That is basically a compiler optimization, which is essentially saying that this function will be called inline. It means that there is no call stack penalty. Essentially what it is doing is every time you call filter, it is copying the code of that function to the place where it's being called. And with that, we've got about 4 or 5 minutes left. Just one thing that I also wanted to finish off, and then we can, if there are any last minute questions, there is the data types over here that I wanted to show if you might be interested. if I can return types. In Kotlin, we don't have the concept of algebraic data types as such, but we do have the representation of them with sealed classes, which essentially means that it's sealing off the hierarchy. So you can, if you are using algebraic data types, which means a type that returns one type or another, you can kind of implement that in Kotlin using sealed keyword, which essentially means that it is sealing off the hierarchy, meaning that anything outside of this nested classes or any class that is declared in this specific file is allowed to inherit from response. Beyond that, it is not allowed to inherit from it. So it closes off the hierarchy. And much like you've seen before, this then allows to write nice, concise code with automatic casting, etc. And with that, I think we're more or less out of time. So if there are any questions, Eric?
Sorry, I was looking for my control panel, and while I was kind of looking at the questions, so there's a couple of questions that we can kind of run through. There's one here: which tool would you recommend to use to measure test coverage of code written in Kotlin?
So generally, there is. Most of the tools that work with the JVM will work with Kotlin, most of the libraries. I think there's one called Jackito, whatever, I can't remember the name. But there are certain issues, I believe, with inline functions where it's reporting incorrect code coverage. There is an issue logged for that for us to try and address that. But generally, whether it's code coverage or unit testing framework or anything that works with the JVM, will work with Kotlin. And one punctualization on that Kotlin is a language that's targeting multiple platforms. So I've covered the language, and the language is pretty much the same, whatever the platform. But we don't only target the JVM/Android, we also target JavaScript and native. So any target of LLVM, Kotlin can compile to, including iOS, macOS, Linux, Windows, and including Raspberry Pi and some eventually some embedded devices. But and the language across all of these is essentially the same. Then there might be differences in certain things of libraries, etc. So when it comes to the JVM, it is essentially interoperable with any existing Java library.
All right, another question is, are there any special concurrency features in Kotlin? So maybe you can talk about like coroutines and things like that.
Yeah, so I haven't covered that, but the way that we are addressing asynchronous programming and concurrency in Kotlin is via coroutines or suspendable computations. So what that means is that essentially there's one keyword that is added to the language, which is called suspend, which indicates a function is suspended in a point of time, and then under the covers, the language, the compiler is creating a state machine to track the point of return of those functions. So the actual implementation of this, or from a user perspective, what this means is that all of this functionality is provided via libraries, and there's a library called Kotlin X coroutines, which allows you to adopt different forms of asynchronous programming, whether you want to use the sync await style, whether you want to use something, combine that with some of the stuff around RX. But the core idea with much of Kotlin is that, in the language, at the language level, we try and introduce as little as possible, and most of the functionality introduced as part of libraries, which goes back to the debate of, a lot of people have been asking for collection literals, and you see that essentially all I've got here for collection literals is a range of 1 to 100. But introducing collection literals is a very hot debate with Kotlin, but in some way it goes against, again, the concept of the language of, these should be provided as part of libraries. But to summarize, look into Kotlin X coroutines, and that's the way that we're implementing it in Kotlin.
Perfect. Another question is, where does the name Kotlin come from?
So Kotlin is the main team that's behind Kotlin are working in our office in St. Petersburg, and it's close to an island called Kotlin off the Gulf of Finland. So that's where the name Kotlin comes from.
All right, so I think we are kind of like running out of time. There's kind of like a whole bunch of questions, but again, we can kind of like, answer those offline. I'd like to thank Hadi for his kind of like great presentation and for, all the kind of great demos. And special thanks to everybody here for taking the time to attend and participate today. Everybody should know there were a couple of questions about that. The webinar was recorded and will be available online in a few days at webinar.acm.org. You can find announcements on upcoming webinars and other ACM activities at learning.acm.org and acm.org. And also, please fill out the quick survey where you can suggest future topics, speakers, etc. On behalf of the ACM, Hadi Hariri and myself, Eric Meyer, thanks again for joining us, and I hope you will join us again in the future. This concludes the webinar for today.